We are done with case 1, which is under first Faraday law of electrolysis. Under case 2 also, we also have 2 formulas. Before I write the formula out, let's state second Faraday law of electrolysis. Second Faraday law of electrolysis states that if the same quantity of electricity is passed through different electrolytes, the number of moles of an element is inversely proportional to the charge of the ions present on the element. That is, number of mole is inversely proportional to charge on ions. Now let the number of mole is equal to m. Therefore, charge on m is equal to quantity of electricity, which is equal to IT. Now, from this statement above, we can say that the mass of one element, let's say the mass of copper, is equal to electrochemical equivalent of copper. Then all over mass of another element, let's say zinc, mass of zinc is equal to electrochemical equivalent of zinc. So the differences between the first Faraday law and second Faraday law of electrolysis is that the first Faraday law of electrolysis involves one element, while second Faraday law of electrolysis involves 2 elements. As you can see, I'm making use of copper and zinc here. While the first question we did earlier, we make use of gold, a single element. But here we are making use of 2 elements, which is copper and zinc. It can also be mercury and zinc. Just name different elements, but the elements must not exceed 2 elements. Now, this is the first formula under case 2. That is, mass of one element is equal to electrochemical equivalent of that element all over mass of another element is equal to electrochemical equivalent of the second element. The second formula under case 2 is similar to the second formula under case 1. Let's recall from case 1. We know that mass is equal to molar mass times current times time all over charge of the element. The small letter q means charge of the element, which is different from capital letter Q, which is quantity of electricity, then times 1 Faraday. But mind you, the definition of second Faraday law of electrolysis is talking about quantity of electricity, which is capital letter Q. And then we know that I times T, current times time, is equal to Q. So definitely we can convert current times time into quantity of electricity. Therefore, our mass is equal to molar mass times capital letter Q, quantity of electricity, all over charge of the element times 1 Faraday. Now, from here, we can cross multiply. That is, molar mass times quantity of electricity is equal to mass times charge of the elements, then times 1 Faraday. Now, since we are working with quantity of electricity, then we can make Q, capital letter Q, as the subject of the formula. Then capital letter Q is equal to mass times charge of the element times 1 Faraday all over molar mass. All over molar mass. Let's recall, we know that mass over molar mass is equal to what? Number of mole. So this mass over molar mass is equal to small letter n, which represents number of mole. So from here we can say Q is equal to number of mole, which is mass over molar mass, times charge of the element times 1 Faraday. So this is the second formula under second Faraday law of electrolysis. That is, quantity of electricity is equal to number of mole times charge of the element times 1 Faraday. But mind you, we are working with 2 elements. Now let's assume that we are working with copper and we are working with zinc. The quantity of electricity of copper is equal to NQF for copper, then is equal to quantity of electricity of zinc, which is NQF of zinc. From here, we can combine it together. That is, NQF of copper is equal to NQF of zinc. This is the final formula. That is, number of mole times charge of the element times Faraday of zinc, of copper rather, is equal to number of mole times charge of the element times Faraday of copper. So this is the second formula under second law of electrolysis. The first formula under second law of electrolysis is equal to mass of copper is equal to chemical equivalent of copper all over mass of zinc is equal to chemical equivalent of zinc. While the second formula under case 2 is number of mole times charge of the element times Faraday of copper is equal to number of mole times charge of the element times Faraday of zinc. So let's solve question using these two formula.